Hey everyone, welcome to a new section. This one is a little special. It's a little different because it's not about a new data structure. We're not learning a structure and implementing it. Unlike, I guess, the past 10 plus sections where it was, all right, this is a tree, let's write one. This is a graph, let's write one. Instead, we're learning and implementing a single, very famous algorithm called Dijkstra's. So Dijkstra's algorithm, it's shortened from Dijkstra's shortest path algorithm. Most people, if you just say Dijkstra's, they know what you're talking about. Well, not most people in the real world, but most computer sciencey people. It's very, very famous. It's one of, if not the most famous algorithms out there. We'll talk about why it's named Dijkstra's, who he was, what he did, and most importantly, what the algorithm does in just a bit. But the first thing I want to say is that even though this is not about implementing a new data structure, there are two sort of prerequisite data structures. One is the graph, because Dijkstra's algorithm acts upon a graph. It searches across a graph. So if you didn't watch the graph content, you definitely want to do that. And then the second thing is that it actually uses a priority queue as part of its implementation. So in this section, we're not going to write a priority queue from scratch because in the binary heap section, we did that. We used a binary heap to implement a priority queue. Now, if you skip that, I understand there's a lot of content in this course and you don't necessarily have to go, video by video, but I am telling you now, you definitely want to go and just watch the priority queue section or the binary heap section, and in particular, the priority queue videos at the end, because that code will come up here. So I'm just going to copy and paste it over. So just as a warning, those two things, graphs, binary heaps, I would try and familiarize yourself with them first. All right, next, let's talk about our objectives. So first, we're going to understand the importance of Dijkstra's that's happening in this video, the history, that sort of thing. Then, as a sidebar, we have to implement a weighted graph because Dijkstra's algorithm works on a weighted graph, and so far we've only done unweighted graphs. After that, we'll begin sort of digesting and understanding the algorithm. Now, it's not terribly complicated, but it gets long enough that me giving you a single slide of pseudocode probably wouldn't be enough. So I have some animations, some videos, or some slides I made to walk through it, some diagrams. So we're gonna just go step by step how it works on a sample graph. Then we'll implement it using a naive priority queue, and then we'll upgrade it a bit using our binary heap priority queue. All right, that's a lot of stuff for a single algorithm. Let's start by talking about what it even is.